Good afternoon, everyone, and welcome to the Lunch and Learn session of Sustainable Ships. This time we're going to talk to Bram van der Boom, or actually he's going to speak to us from a tech binder about his project Smart Vessel Optimizer. And before we start, I want to discuss one single line, the squiggly line, as we just called it in a meeting, which is the most important line for any vessel. It's, of course, your power demand, your energy profile. What exactly do you need as a ship to do all your operations? And this may sound weird, but most ship owners don't know exactly what their vessels need, or their own vessel need. There's usually a lot of, I wouldn't say confusion, but in the hectic operations day to day, lots of ship owners, captains, and even chief engineers can't always pinpoint where energy goes. And that's one of the things. There's a lot of things I can tell you that Bram is doing, but that's one of the things that Bram can solve with the Smart Vessel Optimizer. And it should work for any vessel out there, right, Bram?
Yeah, it's designed to do that. Yeah,
It's
yeah. Of
Well,
course, the output is different per type of operation and per type of vessel, but in the architecture is created in a way that is suitable for any vessel out there.
Brilliant. Well, I wouldn't want to take the grass away from your feet, so please feel free to get started.
Yeah, thanks a lot. So thanks for the opportunity. Short introduction from my side. My name is Bram van der Boom. I have a background more in the process industry and the process automation. So I used to be a lot in and around food and pharma companies, where we used to look at how we could use all the signals that were in a production line in a more effective way for operations. And in 2017, we got in contact with a big shipyard in the Netherlands that had similar challenges as an average big food company and used similar assets. So we thought, okay, let's start a pilot with the technology that's already out there. And that's the start of what Tech Binder became and what we are doing at the moment. So I will start sharing my screen and go through some of the amazing opportunity that you can create if you would utilize digital or new technologies in a maritime environment. And the reason why this is so amazing in my head is that the technology is practically already out there. What we see is that the operations or the maritime operations are lagging a little bit behind on adoption of these technologies. And that has to do as well because there are some extra challenges if you do this on a vessel, considering if you do it on a factory or in a building, because a vessel tends to move a lot more than a factory. So if we go into the presentation, so what I want to do is to spark your interest and to share some ideas and share some use cases that we've already found, where we actually see that there's very low-hanging fruit if you look into digital technology and how it can improve your operation. But before I go into that, I would like to share some global technology trends that we see in any industry. It doesn't really matter where, but that are going on and that are going to impact our operation, specifically maritime operation in the near future. So what we see if we look at technology, we see that there's, on the one side, there's a growing complexity. And that means that if you look at a very old car, everybody that has a technical mindset could potentially repair it if something goes wrong. If you now look at a very new car, you need to be a software engineer with the right software. You need to be able to log in, and it's a lot more complex to fix an issue on a new car versus an old car. And that's a similar thing happening in all the assets that are out there. It doesn't really matter if it's in a factory or on a vessel. You see that these assets are getting a lot smarter as well. So they are guiding operators and giving much more feedback than they used to. And that means that if we look at the second part of this sentence, the commoditization of technology is happening as well at rapid speed. That means that functionality coming from technology is not only for people that can program or really dive into AI, but the functionality is available to a broader sense of people and to practically everybody that wants to use it. But there are a lot of complications in that. So on the one side, it's going to be difficult or more difficult to fix something. And on the other side, technology will be used more as the availability of the functionality is easier to grasp. And if we look at developments in different areas, so looking at artificial intelligence, augmented reality, data and big data, virtual reality, blockchain, and industrial automation, we see that these developments has gone through the roof over the last years. And that means that there's a lot of potential technology and a lot of potential options to choose from once you want to start with digitizing your operation. And now what we see is that these technologies are starting to be integratable with each other. And that's where you create a 1 + 1 is 3. So the speed of development and the speed of creation of new functionality is driving even faster now that these technologies can be combined, and you can focus, or you can create a combined value for your operation. That said, there's a decreasing availability of experts and expertise out there. That means that it's very difficult, if we look at the first sentence, to find people that actually understand the deep complexity of these technologies. And nowadays, technology is, as it is available very easily, the younger engineers or the younger technicians are more likely to replace a part instead of really understanding the deep dive technology in there. And that can be kind of a challenge in the future because, if you have growing complexity, but not the technologists or the people to fix it, and nobody knows how it actually was working in the first place, that can be a tricky area for your operation and a liability. But if we look at a vessel nowadays, we see that a bigger complex vessel can hold up to 300 individual systems that are currently limited or even not connected with each other. They are all producing alarms and signals every second or every day during every operation. And what we see is there's a huge opportunity if you could grasp parts of this data and bring it to a central location in a structured way where you can create insights from it. The challenge today is that these systems are producing these signals every now and then, and either they are lost right away, or they are stored in a local historian inside of the asset and really difficult to retrieve. And there's a lot of other complexity why you cannot compare signals coming from asset A with signals coming from asset B, because there's no synergies or no structure in there. So today's offshore operations mainly require or rely on manual reporting done by the crew. So noon reporting, MRV DCS reporting, filled in by hand every day, every week, every X period per trip. But it is not a high granularity of information, and there is a huge opportunity for misinterpretation of information or failures, human failure in that sense. And what we see is if you can grasp this technology and if you can bring all this data together, these digital technologies offer an opportunity to really create a competitive advantage for your operation in a wide sense and throughout your whole value chain. And that's what I would like to show you with a couple of examples that we have prepared. But before we do that, what we see today is that a lot of assets are getting smarter and smarter, as we said earlier. And that means that a lot of asset vendors as well offer that they provide services or do remote monitoring. The challenge that you want to prevent is that you have all these assets delivering its own line to shore with its own data structure, with its own information sharing to other areas, so to your vendors, if you are a ship owner, of course, to the end vendors where it is being situated in different data silos, because you cannot make correlations between what's happening in asset A and asset B and how they interact with each other. So what you want to do is you want to channel them and you want to structure them and potentially bring them, add their all sorts of other sensoring to them. If you have a structured and centralized database in a cloud environment, you can from there on do whatever you want with it. So one of the things that we see that it is often very valuable to share information with third-party systems like your maintenance system that's now relying on running hours being taken by a person every week. because we have the running hours captured in the asset, we can now automatically share the running hours with your maintenance system. It saves you a lot of time and effort. And because the sample rate of the data is much higher than a human can do it. In our case, it's every 5 seconds, including the high-low. That means that you can do trending and analytics on top of them, and you can depend on it. As today, a lot of reporting is done on paper, and it's being hidden in a folder somewhere, and it's very difficult to retrieve the information together. There can as well be a lot of information in systems that you want to have in your analytics or want to add. So let's say if you want to have weather information or specific water depth or any other information. So what you can do is now, if you have it structured in the cloud, you can as well add that information to your analytics. If you have all that information, what we've seen is that a lot of reporting done currently, Noon, DCS, MRV, ballast water books, they are all based on manual input from people looking at sensors and looking at screens on the vessel and fill something in a folder. And if you have this information in a structured way in the cloud, you can automate all of that. It saves a lot of time of your crew, and it brings a lot more valuable information to the cloud where you can that you can use. And in the end, all the information can be brought back, or is already on the vessel, or parts of it can be brought back to guide operators on the crew during sailing. And I'm going to give some examples over there, what it means for your operation. So where do we see the benefit? Just to give a couple of examples to spark the mind. So what we start with, improving a vessel's design. What we currently see, and that was as well what Vincent opened up with, is that there's designing a vessel, a yard or a nautical architect, he makes some assumptions based on what the customer gives him, what the technical configuration needs to look like for a vessel. So it needs to sail at X speed, this is his time of job, this is the area where it will operate, etc., etc. If you have only 3 months of data already, you can give a much higher or a much more trustworthy operational profile to base your decision, your technical designs on. So one of the examples is that we saw here. This is a vessel, we've monitored it for 6 months, and it's been designed to sail 20 to 22 knots. But if we look over this 6 months, what it's actually doing, you see that it's sailing, well, 4 and maybe 6 knots in average. That means that everything on board of the vessel is being designed to do this, but in practice, it's doing that. And that's like taking a race car every day to the supermarket around the corner. It will wear and tear much faster, and it will deliver problems during your OPEX. And with this information, you can now decide, if you design a new build vessel, or make smarter decisions on how to do your technical configuration. Maybe do this with a battery pack or with an hybrid setup. But this information is normally not available during the design. Another example is in the power generation area. So this is where we see 3 gensets over a year. So this is 1 year of data, and we've monitored the load that they are running on. One of the things that you can conclude, in the dashboards you can zoom in, of course, but all the gensets are running at all time. So that's one of the conclusions. And they are running at roughly 50 to 250 kVH capacity. If a genset runs at less than 20% of its capacity, it will use more oil, it will wear and tear faster, it will create heat. So there's a lot of inefficiency in there. And if you now know that each genset in this vessel has a capacity of 900 kVH individually, that would mean, in theory, that you could go with 1 genset would deliver enough power for the whole vessel. And of course, you want to have some redundancy in some areas, so then you choose to use 2 or maybe 3. But what you absolutely want to prevent is that you have these really small loads on your assets, because they make they tend to make the asset break down and wear and tear a lot faster. And with this knowledge, you can now say, okay, if I would design a new build, what would be the sufficient energy power needed? And of course, we have 1 year of data. The more you have, the better you can do it, because there will be a situation that you are in high winds and high seas, and you need all the power there is. But if we see in general that there's a lot of over dimensioning currently in the technical profile of assets or vessels that not necessarily meet the operational profile there is. If we then go to actually sailing the vessel, so this is something that we've done for an inland ship owner, and this is simply a PDF, so it's not even a live dashboard, it's an automated report, and I've taken some screenshots from it. But what we've done is we wanted to support the captains with sailing more economically and use less fuel. So what we've seen, what we've done is this operator sailing from Groningen to Rotterdam and back in 1 week. So we made a weekly report. And we can do that per trip, per nautical mile, per anything that you want. That's the beauty of this digital technology. But in this case, we said, okay, every 7 days, because that's the crew changeover, they get a report on what is the average speed that they sail per day, what is the distance that they covered that day, what's the fuel per knot that they've covered, and what's the total fuel amount per day. As well, we added the utilization rate, and that's how effectively are you using your vessels. And in industry, this is one of the main KPIs because, vessels are capital-intensive assets, and you want to use them as much as possible, and you want to make as much as possible or benefit as much as possible from them. So this number tells something that there's quite some room, and I cannot tell something about this operation because I'm not a specialist in this case, but this is for this customer to decide. But there is some room to see, okay, how can I get more from the same vessel? One of the things that we found as well is that there are a lot of unnecessary, in brackets, unnecessary running hours. That means that what we've said is, okay, what if you are bunkering for water or for fuel and you know that it's going to take 2, 3, 4 hours? Common operational practice today is that engines are kept on running because it takes some time to shut them down, takes some time to shut them up, to start them up again. Well, by giving this number, so this week we had 15 unnecessary running hours. That means that there is 15 hours of fuel use, there's 15 hours of emissions, but there's as well 15 hours earlier maintenance, because the running hours is the main topic where where maintenance is determined on. And what we've seen is ship captains really want to sail more economical friendly, and they really want to do it at the best that they can, but they simply do not always have the information available to make decisions on. So by giving this every week, the captain can now go back to his trip and say, okay, did I actually need this 15 hours, or can I do with 10 next week? Or where did I really have a high fuel use compared to the rest of the trip? And what we've done as well is in the live dashboard, you can select every location and it will open up in the area where something happens. So let's say if you selected this area, you would see where there was this high fuel use. What was the situation? You can add video imaging. We did that as well for this customer. So then you can bring up the video. You can see what is the situation that the vessel is. Is there a reason why you need to give that much throttle? And actually, this is something we didn't really think of ourselves. So in the Netherlands, a lot of truck drivers and bus drivers get something similar after their days of operation. And it's simply a report that really, it's not to point a finger, it's to help them get more information and make smarter and better decisions. If we then go back to the vessel and bring the information to the operators, we can as well guide operators with all the information that's now became available and help them to make smarter decisions. So what you see on the left, it's a pre-developed application based on augmented reality, that if you look at an asset, it will give you all the information necessary, including step-by-step instructions, including all the alarms, everything that needs to happen. So all your regular maintenance activities can be put in there, and you practically do not need any training anymore. You can help operators with all the information that they need that's now available in clippers or it's not digitized, by digitizing it and bring it into the field really on the asset. If an operator finds challenges, then he has the ability to hit a button that gives you access to a remote expert. So then you can call shore and say, okay, I have a problem with this asset. It's not doing what I want. can we please have a remote expert looking at this? And you can invite an extra set of eyes, a third extra set of eyes. So you can invite anybody that knows anything. So let's say you have a problem with a specific asset, you can invite the asset owner and they can have a look. And this can be done if there's connectivity, of course, during sailing. And what that means is that remote experts can either prevent an operator that they need to go over there, that they need to travel, and that they need to go to port. If there's a need for spare parts, you can order them right away. And I've made a graphic, to show that. So let's say in the past you would sail, and during your voyage an alarm pops up. Then it's up to the crew to deal with it practically during the whole voyage until the vessel is in a port. Of course, they can make notice to shore. Okay, I have an issue with asset XYZ. But nowadays it happens that if this vessel is in port, a expert comes over, and that can be globally, all across the world. He starts his troubleshooting and then discovers either it's something really small, so it's a reset, or there's an emergency button plugged in that they need to unswitch. It's easily helped. So then this guy's traveled across the world for nothing, or he discovers that he needs spare parts. And in that case, he starts to order spare parts at that moment. These spare parts need to be flown in, and then he starts to fix it. That means that your time in port and your availability of the asset is influenced quite heavily. So let's say that you have all this technology available today. So an alarm occurs during the voyage. Having the right instructions and the right information empowers the crew a lot more and gives them a lot more information to act themselves. Should they not find a cure or not have the information available on the vessel to fix it, as we saw that it's going to be more and more challenging to find technical experts and keep them in your company, they can assist for remote support. But now this remote expert has not only the visual of the video, but he also has the data, so the log files, the alarming, what is happening on board of inside of the assets. And based on that information, including the video, they can make a really good troubleshoot and order spare parts if needed up front, which means that if you are going in port and if you need support, the spare parts are there. The person that gets on board knows what he needs to do and what he's going to do. So your first time ride or your mean time to repair will be much shorter, which decreases the time in port and increases your availability of the vessel, which means that you can make in the end more money with it. So where do this add value? So what we see is, if we look at the fleet management or the operation itself, having this information is beneficial for practically all the departments that you currently run in your vessel operation, if you have the right structured way of bringing this information to shore. But one step further is that we see in the value chain, there are a lot of other companies that benefit from parts of the information that you can share. So to give an example, the technical design, having a really up-close overview of your operational profile would help the yard to design a better vessel and to give you better services. We see that a lot of equipment manufacturers will be able to as well design better equipment, but as well help you faster and on your way again. And so, of course, the end user, they will be able to plan much better, know where the vessel is, what is the vessel doing. There's a lot of calls going from an end user to captain every morning. What are you doing? Where are you? How long are you in port? What is the expected ETA? All of that can be automatically brought to the end user in a live dashboard. And there are a lot of other examples that we've already just found out that you see that there's a lot of opportunity here to improve the way that you work together with your value chain partners. So a little bit over TechBinder. So TechBinder, as the name suggests, we combine technology. So we are an IoT system integrator. We work with partners. Schneider Electric and Aviva are the biggest ones. And our aim is to improve human-machine interaction. So what we see is that assets are getting smarter and produce more data, but not necessarily this data is being transferred into information, and that information needs to be brought to the right person in time. On the other hand, we see that there's a lot of expertise hidden in the heads of people, and if it is hidden in the head of in a person, you either need that person on site to have the information or via a suitable video call. But if this person disappears, goes on pension leave or go work for your competitor, you will lose this knowledge. So what we do is we combine that in a digital format, and we make sure that information is being shared and captured as well for future operations, and you can learn from it continuously. So doing that this way, we create more effective and efficient operations. If we look at our full portfolio, we turn practically already available data into information and bring that information to the right person in time, anytime, anywhere. So to close out for now, I have some tips, tricks, but we've noticed we work on this for a little less than 3 years now, that we see going wrong or that you need to keep in mind when you start with this. One of the things is to start dream big, get this really nice big dot on the horizon, call it autonomous vessels, call it the digital twin of the future, give it a nice name, call it the digital operations. But have that really big dream, but then you need to start small and tangible. It really it goes a lot of times this go wrong where people start to do this and that and not coordinate the road towards that big dream. You really need to start small, and that's as well where sustainable shipping can be a part of you of the journey and can support you in your guidance how to get the most out of these tools. What will be a suitable roadmap to go to there? Think ahead. A lot of initiatives currently start, but they do not really have that big dream in mind. So please, the decisions that you make today, you do not want to design a system that is in the end not usable because it's not cyber secure, it's not scalable, it's for some reason not connectable to another system. So please think ahead of this big goal and base the decisions that you make today on that dream. One of the big things is partner up. This is a whole different ball game, and it's out of the normal core business of a ship owner or a shipyard. And there are a lot of companies, like ourselves, that really know what to do and how to do this, and they can move. You can move a lot faster and a lot more agile if you partner up. And what we see is developing this yourself, maintaining it yourself, keeping it cyber secure. It's a hell of a job, and it will, in the end, cost you a lot more than just go with a partner. And one of the things that's going wrong practically all the time is that there's no focus on business. In the end, we are solving a business problem. We are making sure that you are going to sail more ecological friendly. You are going to make more margin. You are going to sail more effectively. It's a business proposition, and the tools are digital and technical. And too often we see that there is a really interesting digital setup created, but there's nobody thinking about the actual business goal. And the last one that I would like to give to you is you need to start as soon as possible. These systems get smarter the more information gets in there. So that means that if your competitor starts today, in 4 weeks, he will have such a big head start. And this is something that is going to happen. We've seen it in all the other industries. And it's almost a waste to not start today. Thanks a lot for your time, and please feel free to ask questions, because I look forward to the discussion.
Thank you, Bram.
Thank you.
Amazing story. Really, really good. Thank you.
And it's only the tip of the iceberg. We can talk for days about this.
Well, I think last time we talked 2.5 hours. So
yeah.
I want to leave the digital room for questions from others. So you're writing down some questions, Stefan. Maybe you can start.
Yeah. First of all, thank you for the presentation, Bram. It's really impressive, I guess, and also for a lot of ship owners how you can use the digital innovation, because a lot of people are thinking of it maybe, but you made it really concrete how you can use it. But maybe to go into detail about that, how can you, if I'm a ship owner, how can I implement Smart Vessel Optimizer within my ship? How does that work?
Yeah, so we made it plug and play in the beginning. So what we've seen is each vessel is different. There's a lot of legacy assets, specifically if you are going to do a retrofit. So what we've created is a way or a small cabinet that includes its own IoT. So practically by putting the cabinet on board of the vessel and powering it up, you can start. But the interesting thing is starts when we start the discussion. Okay, what is the type of operation? What is where are you currently losing money, or do you really want to improve at this moment? And then we are going to see, okay, what information would help to make smarter decisions, act faster, prevent that something is going to happen. And that information needs to come 9 out of 10 from the assets that you already have. And that needs, then we need to understand a little bit more about the technical configuration of the vessel. As it is today, we can connect to 600 different PLCs and a little over 100 industrial communication protocols. So I would say 90% of the assets we can connect, whether it is CAN bus, NMEA, Modbus, TCP/IP, it doesn't really matter. And if it is something really specific, or it's an asset that simply does not have any information, we can add some sensoring to it. So we made it very easy and very tangible, and you can start really, really small tomorrow. What we as well thought of is we have now 10 journeys defined. So these journeys are strategic goals for ship owners and shipyards and OEMers, so people delivering services on board of vessels. And what we said is, okay, if you want to save energy, we have all the steps and all the technology ready. It's up to you if you choose for that journey. How long you want to take to go there, it's as well up to you. You can do it in a month, you can do it in 10 years. But by giving them the journeys and the plug and play start, and then the journeys, it really helps the discussion to see, okay, what can I do and what do I need to do, because it is out of the comfort zone and out of the core business of a ship owner. That's what we see. Yeah. The digital mindset is not that mature at the moment in shipping yet.
To improve.
Yeah, true. But I think if you can start really slowly by first having the dashboard and connecting maybe a few systems, then you can also see the benefits, and then you can also visualize what you can do more if you connect more systems, and then you can dive into the journeys what you want to take, and then you can.
What we see, so what we did for the inland shipping company, we started with a simple PDF, a weekly report, and by just starting doing that, a lot of questions raised. Oh, I would like to see that. Can I share this information with my legal team? I don't know, or with my planning, and then the belief in the mindset and the ideas pop up automatically, practically, and that's a really nice journey to work together to really see, okay, how can we support the operation? Yeah.
Cool. Do you have any more questions, or?
And maybe about the packages, because can you either buy the smart vessel optimizer, or do you automatically also get the artificial of the augmented reality support together with it, or how does it go?
Yeah, so it's all modular. So sometimes a customer already has a specific functionality, so then we say, okay, keep it because it works for you, and we create something. It's like a Lego block. So there are a couple of modules that you can choose from. You can do only the remote support, for instance, or you can only do a PDF every week or every month. But you can as well do predictive maintenance or in a whole virtual model where you can walk through the vessel. And what we really want, so the technology is available. That's what we would like to state. We're working with our partners. We do not develop all of this ourselves. We do some stuff ourselves, but not a lot of not everything. And with the end user, it's to decide, okay, what model do you choose and how do we align it into your IT infrastructure, into your operation. So it's like building up a Lego blocks. That's and it's all integratable, but you can use it separately as well. Yeah.
Really nice, and I think that focus on the client is also nice. That you can just choose, I want this and I want this because that is already working well. And
it is what you say. So you can grab the low-hanging fruit first and start with something that makes an impact for that specific operation or for that specific customer. Even having a vessel, that's a great entry point. There's always one vessel or one asset that gives problems, and by connecting it and bringing the information to shore, you all of a sudden have a lot more information to see, what's the reason that this asset is failing, or that this vessel is using much more fuel, or and that's always a nice trigger to see, okay, if that's a big issue, let's tackle that, and from there on, see what we can do together. Yeah, and build further. Yeah.
It's like having solar panels at your home. Once you start measuring, you get addicted to the power output and how it works. Yeah.
We had this famous saying from a customer. He said, before we started doing this, we were very happy. And after we started doing this, we noticed that we were very blind at the time as well.
Ignorance is bliss. Yeah.
It is like that. So there's you learn a lot, and a lot of unexpected things pop up. That we do not expect as well. Yeah.
I have a very practical question. So suppose you have a vessel and you say, okay, Bram, do whatever you need to do. You come on board with the box, the Pharos, I believe it's called.
Yeah, exactly. Yeah.
Where and how do you connect it? Is it standalone sort of a PC unit that connects with all the machinery? Are there sort of standardized brains inside vessels, sort of central computers, or how does that work?
Yeah, that's a good question. So there are a couple of areas where there's a lot of information coming together. So think of the alarm monitoring, or of course on the bridge. You can plug in there, and we only copy data. So there's no way that we can that somebody or anybody can write on the asset. So we only copy the information, and it depends a little bit on the functional outcome, what you need to connect, and where you need to tap into. But let's see. So the VDR has a lot of information. The alarm monitoring systems have a huge set of information. For fuel, you can install fuel flow meters. But to start with, you can simply connect to the CAN bus of the engines and the gensets and get the fuel and the load out of there. It's a calculated value, but it's much more than that you practically have today. There are a lot of options, and what we've noticed as well is that a lot of the information is available in multiple systems. So we simply need to see, okay, which system has the availability for I/O input output I/O-X, and how can we connect to it and bring it to shore in an agile way. Yeah, or add a sensor. That's even more. That's the easiest part. So we've now a customer that wants to do condition monitoring on its gearbox. Mm-hmm. And it's a mechanical thing. There's no data coming out of it. But there we use the external sensors and with pressure, temperature, and vibration, I believe, that now continue or monitor the condition of the gearbox in this sense. Yeah.
True technical Lego.
It is. Yeah, it is actually. Yeah, and. Yeah, one of the things. So in the cabinet already a lot happens. So we determine status, for instance, of the vessel. So what you can do is you can compare all the vessels that are sailing. And you do not want to compare a vessel with that's in a harbor and a vessel that's sailing against the high winds. So what the cabinet already does is it's determining: am I idling? Am I moored? Am I navigating? And with that status, you can then say, okay, I only want to have the condition of my gearbox when I am maneuvering, for instance, because then there's a lot of clutching going in and around. And that call it metadata has been given already to the with the cabinet, and then you can really up close compare different types of operation with each other.
Really cool. Yeah. Nice. Let's see if there are any more questions from the chat.
Yeah, very quick question. Thank you, Bram, for the slides. The question is: after the box, what happens? How does the data flow from the box on the offshore to the I don't know, maybe monitoring facility and the headquarters, for example? How the data flow all the way to that point?
Yeah, that's a good question. So you mean in the connectivity sense?
In the connectivity sense, yes.
Yeah. So there are multiple options. So the cabinet is standardized with on a 4G or 5G SIM card, which would mean that it will store all the information during sailing, and once there's a suitable connection, you would get a backfill. It will be sent via 4 or 5G. So normally you see that between 4 to 8 kilometers offshore, you get an update of the data. If you want to have a higher throughput or more how do you say it, up-to-date data, you can simply plug it into the satellite, and then it will use the normal satellite configuration. You can as well choose for a separate dedicated satellite that is capable of switching between 4 5G and satellites. There are multiple options. The customers that we use today, well, we see in the inland vessels they use 3 or 4G. That's easy, and the offshore vessels they use the satellite at the moment. And the cabinet is equipped with industrial data cropping technologies. So looking at the competition, we need roughly 10% of the bandwidth to send the same data over, because there's very strong cropping, and there's some technologies in there to keep a package as small as possible, but to keep the output of the package as effective as possible. Did that answer your question, Omar?
Yeah, that's actually what I wanted to inquire about. The other thing, very quickly. So, for example, if a customer needs to have like some sort of predictive analytics of some sort, say maybe Aveva Prism or Aveva Connect with this cloud, right? For example. The question is, which way? Like, I mean, I understand probably the customer's way of doing things will probably decide on that, but based on your experience, guys, I mean, like, would it make sense to have this predictive analytics installed on board the ship, or maybe sent to some headquarters somewhere, and then have some reliability or maintenance engineers monitoring the fleet almost in real time? So the question is, where probably would be best? Would it be centralized somewhere onshore, or maybe it's better to have it installed on board the ship, or maybe a hybrid thereof?
Yeah, that's a good question. So again, there are some options or choices to make. So if you want to have of course, if you want to have the information on board and you have the people on board, so that you see on the more big and the more complex vessels, or DP vessels, you would preferably do all the calculations on board, because you simply have a faster answer, let's say. For normal operations, so an average tanker, an average tugboat, or inland vessel, it's more than suitable enough to send it to shore and then do the analytics centralized. The extra benefit that you get there is if you have multiple vessels. So let's say you have a fleet of 10. You can start to compare these vessels more easy if you do it in a central location than when you do it on each vessel individually. So once something happens on vessel A, you can immediately copy paste it to the other 9 and benefit from the learning that you have on that vessel A. There's as well a hybrid model where you start to synchronize, but that's, I would say, more for the cost add up as well. So you need to see, okay, what is beneficial for the type of operation. So if you are running a DP operation with multiple vessels, these vessels cost 2 or 500K a day, for instance. And if they break down, it makes sense to have a system like this. If you look at an inland vessel with a cost of 3, 4, 5K a day, it doesn't really make sense to do this on each individual vessel. Plus the amount of tags that you would get from an inland vessel, they will never reach over 150. I would assume that would be enough already, or a lot already. So it is very easy to send that to shore. If you go above 1,000 IO and really need a really fast calculation, I would say create something on board of the vessel, and maybe even use OCSoft to do that.
Okay, thanks. I probably need. You mentioned at the beginning of the slides that you have 9 steps or stages of the journey, or something like that. Yep. Can we find any information on that somewhere?
If you send me an email, I can send you the journey book, which we've done, we make, and it gives a little bit more information about the 10 journeys. We are working on 5 others that will be released somewhere by the end of this year. But if you send me an email or I can share it, that's no problem. We have it available.
Good. I'll drop you an email after this session.
Yeah. Thanks a lot.
Right.
Yeah.
Thank you very much.
Any more questions? It's all super clear.
Nice.
Really excited. Really exciting stuff, Bram.
Thanks.
Really cool.
Yeah, I think the interesting thing is that this is at the forefront or about to burst in the maritime market. That's really my feeling.
Yeah.
And